Here's the dart gun I took to OpenSauce 2023. Sadly, I lost all the footage to that, but that's a story for another time. The plunger broke halfway through the event, but it still does fire if you can get it to lock. So I got curious and wanted to see if I could salvage some parts and design my own. And it all starts with a humble screwdriver. Taking off these 3 screws gives you access to the barrel underneath. Pretty neat, but it doesn't give me very many answers to my questions. So I'll go for the plunger next. The thing I realized every time I opened up this thing was that, unlike one that has a slide, the pull mechanism is baked right into the air chamber, or whatever it's called. It's pretty simple though, only consisting of the piston head, an O-ring, a spring, and the bottom plate all skewered together. You can only really see what's behind this part by prying it off like a monkey, as you see me doing here. Monkey with a chisel, that is. And there's this weird piece hanging out in there. My only assumption is that it's used to limit airflow, making the dart impact softer so you don't lose your eye like your mom always warned you about. So you put a dart into the barrel and it compresses the spring this piece is attached to, opening the air valve. Then you fire the dart and the spring rapidly decompresses, cutting off the air supply before the dart's even left the barrel. I don't think we can really get any of this open. I mentioned earlier that this gun is broken. For some reason it just stopped locking into place without encouragement. Maybe I had enough obeying the laws of gravity. So the majority of the design seems pretty straightforward to me. The only things I need to consider are the shape of the trigger and how it latched to the plunger. And don't mind me feeding the camera here, I'm trying to get a good focus. This right here is the million-dollar question. I also have to make sure that the back plate isn't going to burst out the back and hurt somebody, like the Great Spring Event in 1972. Because this high resilience spring gets real small. I'm not even sure how they were able to keep the threads. As you see, it's just the plastic holding them in place. Just the ABS. Oh, nice. If you look into the bottom with the plunger removed, it's just darkness and space. Wonder if anyone can hear you screaming there. So, this is going to be my project. Design something that can utilize this and fire darts. Designing time. But wait, before we start designing anything else, we gotta make sure the screws are gonna pass. The vibe check. I have these heat set inserts that have actually come in handy for a lot of projects. I'm hoping these screws are metric so I could reuse them instead of adding to my already full pill container of spare screws. But I guess in the end, more never hurts. The screw is neither an M2 nor an M3, so I'll have to pull some new ones. Unfortunately, these are going to be banished to this new screw hell I just learned to design. Bye bye. But then I realized I have to use these to find a screw somewhat proportional to the old ones. I like my screw assortments very much. M3 is a little bit thicker, but I would trust its strength more compared to an M2, which is a little bit thinner. Where's Goldilocks when you need her, man? I mean, they. And let's put the rest of these screws away and start designing. But wait, before we even think about CAD, we gotta take measurements. My tools of choice are a notebook, caliper, and a writing utensil. The way I like to do it is by taking my part and tracing it with a pencil like so, and then I'll take the caliper and measure the drawing. Gotcha. This isn't the way I do it. I mean, I still trace the part and break some lead in the process, but it makes it easier to visualize the measurements than if I were drawing each section separately. Oop, more broken lead. and copy my real measurements from earlier, then everything else. You see how I've denoted the measurements on these circles? More on that later. I'm going to add a little decoration here so I know this is the spring. Finished measuring the last piece for the plunger. I'm drawing this pair of scissors because I might try to cut off this handle and adapt something else to it. I had to pull this one to measure how far out the bottom of the gun the lever sits. I want to match the power of the original as much as possible, if possible. Anyone else think pencil lead is getting kind of expensive? Hey you. Get your head back in the game. We're working here. We'll round that one up. The spring is a tricky one to measure. And lastly, the dart. One thing I forgot to address was the interface between the air chamber and the barrel. There's a hole in there that stops the piston head from busting out the top. I am sadly unable to measure this with my calipers. But you know what? The piston head has an anti-hole that I'm confident is the same size as the elusive one in the body. But not confident enough, so I'm going to mark the very edge and see if that dot appears on the edge of the hole. And I do see it here, so I'm going to go ahead and measure that. And finally, it's design time. I came up with an idea in my head that I'm just going to try and sketch out on FreeCAD. And here's where I messed up earlier by denoting the piston's diameter as a radius. I was very confused when making the exterior of the air chamber, and it was smaller than the interior. But I figured it out eventually. I love this constraints game you play while designing. It's therapeutic to me. I wasn't going for any fancy designs as this was just a proof of concept, so I just made it a straight barrel. We'll also add those little vents I saw inside the original gun because they're cute. I made a flower, or button. I was going to do just cylinders for the screws, but I felt like adding little domes to the top of these, for style. My revolution wasn't working, and it stumped me for a while because even though it was all lined up through constraints, there were wires that weren't connected. Here I finally found it, and we're in business. I'm in love with the simplicity of this design so far, but one thing I didn't consider was where the trigger was going to go. Quick thinking to the rescue, I created two walls that would be able to hold it off the side of the air chamber. Take note of the size of this hole for later. And I made the holes for the inserts, but I was worried that the walls would be too thin. Now I had to confront the trigger. I analyzed the way the trigger on the original gun was designed and came up with something simple. Here's the finished part in all its glory. Let's go ahead and print it. Well, I tried to, but the lack of a flat base made this print fail several times. Luckily, I caught it before it got out of hand and I wasted too much filament. So I added these bars to give it a nice edge to sit on. Now it's really off to the races. So I printed more, and some more, and some more. Whew, this is tiring. I printed a little more, then went off to bed and let the printer finish doing its thing. Good night, buddy. I wake up this morning and find my camera busting it down sexual style. Woo! Come on, man, we got work to do. Get yourself right. I need a sip of Joe. Goodness. Oh god, that's a good roast. What the fuck is this? Nah, we'll play with it later. I forgot to record the support removal process, so here are all the parts I'm going to be using all together. Starting with the bottom plate, I'm pretty impressed with how it came out. No major flaws other than the print orientation disintegrating any structural integrity this piece will have. But I have faith. And here's how it compares to the original piece. Now Keith. Here's the trigger, also looking great. I decided to shave the latch down a little just to be safe. Last but certainly not least, the chamber. All I gotta say is this thing is a real beauty. The supports came out so much cleaner than I anticipated on the inside. I set the inserts, then realized I didn't record a damn frame of that. This thing has such a vibe, I'm in love with it. Here's where the other fix comes in. Remember that pocket I made for the trigger? Well, I had the insight that maybe a huge hole where the piston rides isn't a very good idea, and I made that very much smaller. Also, FreeCAD would crash whenever I would try to edit that sketch. I thought I lost all my work, but by sheer brute force I was able to modify it. It is time to assemble. Yeah, I'm not too confident in that bottom plate, but I have faith. I don't think there's enough clearance for the plunger, and I am mentally preparing myself to go back into FreeCAD and tweak some things. But it looks like it did go in, which triples my confidence that this thing might fire. Now I'm taking it out because I decided I want to install the trigger first instead. And it looks like the pin is going to take some convincing too. This looks like it might latch. Now the piston gets its turn. It looks like the first screw hole cracked, so now I know the tolerance was bad all around. Assembly is complete. Oh, dang it. We lost that screw hole too. Let's see if it latches. It looks like the center of mass causes the finger end of the trigger to teeter downward instead of the latch, but that's okay. I'm a persuasive guy. Oh my god, the inserts are slipping out. Maybe we can get one good shot out of this if I hold it with my thumb. Well, to the range. Oh, that's a little tight too. And it actually fired. Nice. But Will it fire again? Two for two. That's amazing. Now the inserts really aren't happy, but it's locked and loaded, and I'm expecting this dart to just flop out if it even moves at all. And it's still got some power, so it's back to the sketching board. Since it was already broken, I tested the structural integrity off camera, and yeah, as I suspected, the barrel joint to the air chamber was very weak, and it doesn't seem to break easily anywhere else. I'm able to get a better look at the flower vent though. The body really held up and didn't get straight up annihilated by the plunger. All I have to do is increase the clearance on the piston head, the barrel, and the peg, and I'll actually be decreasing the clearance on the inserts to see if that helps with the pulling out problem. I did just that, and now running off the next revision. You can see I laid the bottom plate flat this time to try eliminating the possibility of it blowing the spring out its ass. I was genuinely curious to see how the supports would handle it, and it seems to be doing a fantastic job. Oh look, a fan. So I'm letting it go, and while I wait, I'll practice a little letting go myself. The bottom plate is looking good, but I noticed some gaps in the top that are a potential weak point, and I figure since the plate and trigger are done, I'd try to take them off, but I have no use for them without the chambers, so I'll leave them be. The whole print takes about 4 hours a pop, and I was eager to get to work on the second revision. This is my way of removing hard to reach supports I like to call the twist and pull method. You just take a trusty pair of pliers or tweezers and take out the chunks of supports by, well, twisting and pulling. You see it doesn't get it all at once, which would be ow! Remember, tweezers can be very sharp, so handle them with care. It's always super satisfying when a whole rose comes out of the piece. And all that's left is fishing out the supports attached to the flower vent. It's more challenging to remove those last few bits this time, so I'm calling for reinforcements. And just like that, clarity. Now for the bottom plate, I'm using the tweezers again and just prying the supports off. Here's a better look at those gaps I was describing earlier. It also seems pretty structurally sound now that the grain is on the perpendicular axis. The clearance for the screws this time was just enough. The piston slides in a lot easier this time, with almost no resistance, which concerned me a little bit. The second screw seems to have seized halfway through. It won't budge. And then I realized what happened. You see, I added this edge to the bottom of the gun so I can ensure the plate was aligned properly because the screw holes are not at square corners. However, in this still, you can see I got it backwards, despite reminding myself before even pushing the first screw in. And furthermore, I put the screws in diagonally, so this one got misaligned in the insert and the threads wreaked havoc on each other, locking them in place. I'm trying a different bit set, an Allen wrench. I'm desperate now and even trying a Phillips head, but the screw head didn't strip. Oh no, all of my bits did. In what I'm now calling a savage attempt at removing just the bottom plate, I snapped the barrel off the chamber and broke the lever on the plunger. The trigger did nothing wrong, but I'm mad at it too. It was kind of tough, but fortunately I was able to salvage 3 of the threaded inserts. The strength it took to release them actually gives me confidence that they won't pull out again once I got it assembled right. But I lost my plunger assembly, so now I'm thinking, what am I gonna do? That was the whole backbone of the project. I got 2 of these for open sauce, so it's no question. The show is going on. I left a print overnight and woke up early in the morning to find it failed due to tangled filament. So I ran it off one more time and got it. and assembled it properly. It looks like the spring is pushing on the bottom plate a little bit, but I think it's much less of a risk than the other way I printed it. And the inserts are staying in place. Heated plastic must have pulled up and split here when I added the inserts. So, will it fire? Let's try that again. I already know it pretty much boils down to that increase I made in the piston head's clearance, but I have to find some grease or something to seal the gap. Well, I don't have grease, and I can't just go out and get some because my car's in the shop. I did, however, use a few layers of masking tape to decrease the gap, and it feels much better now. I also found this bit set tucked away in the storage, and it had exactly the same bit I lost in 2 screwdrivers and an Allen wrench. It fit one of those screwdrivers perfectly. But anyway, that fix worked, and this thing is kind of addicting. Chess! Ow, hey! Alright, enough messing around. Let's get a distance test. I got an average of about 28 feet per dart, 3 of them landing 25 feet away, and 2 going as far as 45. So the last thing I need to figure out is keeping the trigger suspended so I wouldn't have to tilt it while I pull back on the plunger, but I need a spring small enough for what I have planned. Fortunately, I was able to dig through my box of crafting goodies and find a brand spanking new mechanical pencil to replace the old one I was about to defile. In usual fashion, I will take my screwdriver and, wait a minute. This thing doesn't... Screwdrivers are supposed to open anything. Somewhere in here? No. Wait, I got it. Let's try the Jaws of Death. This spring is as thick as my trigger, but I can make it work. My first idea was just to drill out the trigger I had already. First by using a hand drill, but that was too slow. And the larger drill bits didn't even work. I upgraded to a battery powered drill, but the fear of it biting the plastic, breaking everything, and tearing my finger off was too much for me to continue this way. Also, the time I spent here could have been used to drill the hole out digitally, which I did end up doing. In case anyone's wondering, here are my print temps. Whoever introduced this nozzle cleaning code is a genius, but unfortunately it'll make my nozzle worse if I'm not intercepting the purge material like this. And it's off to the... Wait, what? It started printing all the parts again, even though I exported just the trigger as a different file. So I re-uploaded it. And it's off to the races. Let's go. At this point, I'm partial to not reprinting this whole chamber with a minor modification to keep the spring in place. Not only because of all the failures, I'm also very much running out of filament. So, here's my solution. The 3D pen. I've had this for a while, but this is the first time it's getting a practical application. It just takes a while to feed and purge. I'll mark roughly where I want the spring to stay. There's a seam from the printing that will help me align it to the middle of the trigger. It was kind of awkward to work with the pen considering I write with my right hand and the USB port was far to the left, but what I'm doing is just making a base to give the peg a little more surface area on the body. Then I start extruding on top of that in thin columns to build the peg, and mold around it to give it a more cylindrical shape. Now that that's done, let's check on the print. Almost done. Just enough time to grab a coffee. Alright, let's take our print from the heating plate to the cooling plate. I found that a slab of metal like this really helps the part release from the build plate, especially when not using a glue stick. I didn't consider that printing this way would result in a very weak point, right here in the trigger, and it may even break when I try to remove it, but I have faith. So far, so good. I'll just try to carefully remove these supports. Beautiful, let's put it together. Perfect clearance in the trigger, and for once I'm confident the peg will align with the spring. Couldn't have done it better myself. Self-latching, at last. And in the end, I got my hands on some grease. So I slapped some in there. And there it is, a reconstructed dart gun from salvaged parts. I'm happy with how it turned out, and will use everything I learned for a future project. I wanted to get another distance test with the grease added, but a dart failed to fire. Then the trigger broke, and I launched a dart over the fence.
Oh. 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 Oh.
So I guess that's it for now. Goodbye.